This is 4.7 in your textbook, inverse trigonometric functions. In part 1, we'll talk about inverse sine, inverse cosine, and inverse tangent. Alright, so we'll talk about specifically what does it mean to have an inverse trig function, what the graphs look like. We won't do as much with graphing this time around. The domains and ranges, those are really important. And then how we would use the unit circle to help us evaluate these problems. Alright, so let's remember back in Algebra 2 about inverse functions in general. They switch the input and output. So in our original trig function, we input an angle and we got a trig ratio as an output. We input 30 degrees and we got 1/2 or √3/2, etc. For the inverse functions, we're going to put in the ratio, and our output will be an angle. So we use this in some basic problem solving when we know the two side lengths of a right triangle. We can find the ratio of those two side lengths and use that to find the angle between. So, as just a reminder of what this looked like in previous classes, if we take x squared, the parabola, its inverse is the square root of x, and they had graphs that are reflections over this line y equals 1 that goes along here. Or sorry, y equals x. So, these graphs, like the parabola and the square root, are reflections over this line as well. What it makes it look like is that we've just turned the graph and gone in the opposite direction. So instead of going side to side, the inverse sine graph goes up and down. But the problem here is that we no longer pass the vertical line tests. So whereas this is a function, this one is not a function. So to take care of that, we limit the pieces of the graph we look at. So for sine, and the inverse sine, notice that this uses the terminology arc sine. That's another way of saying inverse sine. It comes from because you know the ratio and you're finding the radians, the arc around the unit circle. So we limit sine from negative pi over 2 up to pi over 2. Cosine is limited from 0 up to 1, looking at the y-axis. And tangent, we don't really need to worry about this, but we only have one iteration of the tangent. It doesn't keep going, we don't see another curve up here or anything. So we only go from negative pi over 2 to pi over 2, just like sine. So these two have the same range. So in a chart, which you should pause and write down, we have our three domains and ranges. So the domains for sine and cosine are limited from negative 1 to 1, which was the range of the original function. And then the ranges have been limited in all three cases. Sine and tangent are negative pi over 2 to positive pi over 2. Cosine is 0 to pi. So, when we look at the unit circle, I'll show you how to use this a little bit here. I'm going to call sine green. I'm going to use purple for cosine and this gold color for tangent. So sine is going to be any of these angles found from negative pi over 2 up to pi over 2. Cosine will be any of these angles from 0 to pi, and tangent will be the same as sine, any of these angles here. So tangent, cosine, and sine. So if we're asked to find the inverse sine of 1/2, we're going to look within that green arc here. We're going to look where the y value is 1/2. So I'm going to look at these y values all along in here. And I see the y value of positive 1/2 here at 30 degrees. For the inverse cosine, we're going to look along those purple values there. We're going to look where the x value is negative root 2 over 2. And the x value is negative root 2 over 2 over here at, I'm going to do radians this time, 3 pi over 4. And for tangent, we're going to look at y over x. So it helps to kind of have these memorized to an extent. So basically, if y over x equals root 3, then y had to be the root 3 over 2, and x was the 1/2. So that happens up here at pi over 3. Sometimes you'll see these functions within a function. So the inverse sine of negative 1/2 happens down here at 11 pi over 3, or sorry, 11 pi over 6. And then if I take the sine of that, well, I just looked for where the y value was negative 1/2, and then I'm asked to take the y value again. So actually, these two just cancel each other out, and we're left with this value. So that's it. Make sure you take some notes and be prepared for the short quiz tomorrow.